So hello everyone, welcome guys to this GFG POTD week of day 157. Let us see what today's question is about and we can think of the different approaches and then code off. So today's question name is divide in incremental groups. The tags here are dynamic programming, mathematical and data structures asked in Expedia. So let us jump back to the question again. So it is saying it's a hard level of question again. I don't know why the accuracy is 88.95%. uh, I tried to solve this question. It has taken a very, let's say, huge amount of time for me to solve it and let alone explain it to you guys, right? So it's the same question. The approach that we'll be handling here, it will be like running a recursion inside a for loop, right? So there is one question on the recursion playlist, and the name is like printing the permutations of a substring, and there also there is a recursion running inside a for loop. So if you are not aware of that problem, that how the problem is approached, or maybe how the problem is coded, then you might get a little what if maybe uneasy to understand the code of this question as well. But let's see that what it is about. Yes. So given two integers n and k, that the task is to count the number of ways to divide n into k groups of the positive integers, such that their sum is n and the number of elements of the group follows a non-decreasing order. That is that it should follow an increasing order, and it should be in increasing, and the elements can also be equal, like 1, 1 and 2. It's still in increasing order. You can see the elements can be equal, right? So for n equals to 8 and k equals to 4, they are given these answers, right? Okay, but we will solve for lower test cases, right? Because in recursion, we always do this thing. We try to solve and think in a lower test case, right? And then we code that approach in the leap of faith that it will run for the larger one as well, right? So, okay. So I hope you are clear with the question, that what is it is saying, that you have to form a group consisting of k elements such that it should be an increasing order, first constraint. Second constraint, such that it should be the sum of those elements should be equals to n, right? Okay, so let us start from the ekdam, like when you see the question, that what first thing comes to your mind, right? So first thing is that form all the iteration, form all the permutation, and then try to uh, place some logic on it, right? So you can see that the for n equals to 4, k equals to 2, the output will be given as 2, right? So let me compile and run for that as well. I have it in the test case here. Let us see what's the output, and then we will proceed ahead with the logic. So it is 2, right? And how it is 2? How it is 2? That the array to be considered is this thing, 1 2 comma 2 and 1 comma 3, right? The sum is also equals to 4, and it is in increasing order. Okay, so what can we do is you can see this column here, right? You can see this column here, and you have just two places to pull or to put all your values, right? Whatever values is possible, right? So let's fix one place, the last place, right? And what are the values that you can place it with, right? Clearly you can place it with the numbers, the integer numbers that is present in the end. You cannot go beyond this 4, because if you go beyond 4, then definitely the sum would be greater than its, and it will be violating our first condition, right? So I have fixed the numbers at first place, the last digit as 1, then the second as 2, then the third possibility as 3, and the fourth possibility as 4, right? But you can clearly see, and one more thing, that when you place a number as 1, then the possibilities of this second place will be, or in this case there is a k equals to 2, let's say it was k equals to 3, then the possibility would have been the sum of rest of these places. The rest of these places would be equals to what? N minus the last digit you have placed here. That is, the target sum will change from x equals to n minus x, right? So that is what. So 4 minus 1 will be 3. Similarly, 2, 1 and 0, right? But you can clearly see that in this possibility, there will be several other possibilities as well. So when you have fixed the last integer as 1, there would be 4 more possibilities that you can either place 1, either place 2, 3 and 4, right? Similarly for 2, you can see 1, 2, 3 and 4, and the last is fixed as 2. Similarly for 3, you can again place this. So these will all be the possibilities, right? Among them, we have to see that which are all the sub arrays, let's say, or groups, which is satisfying both the conditions. That is, the sum is equals to n, and it should be in increasing order, right? So there is only two cases possible here, that is 2 comma 2 and 1 comma 3, which is satisfying all the constraints, and none of the other sub arrays are satisfying it, right? So if I tell you to write a simple recursive code for this thing, for the things which is happening in the diagram, would you be able to? So I highly recommend you to pause this video and think of a recursive approach and code off, right? So I hope you were able to code it as well. If not, that's not an issue, right? Let me code it for you and then we will explain. Okay, so that's the code I have written, right? So let's say you have a parameters, function parameters are n, k, and comma last, right? The last is nothing but the last digit that you are placing, 1, 2, 3, and 4, right? And since you are placing each and every integer present in the range of 1 to n, so you will be needing a for loop, right? So that's what I've written here. For equals to s equals to 1 to s less than equals to last. Last is nothing but when we will pass the function, it will be equals to n, right? And s plus plus, and you have to consider all the possibilities, whatever the answer you're getting from this thing. Let's say you don't get any answer from here, you get one answer from here, you get one answer, so you need to return the summation of all these recursive calls you are making, right? So that is why answer plus equals to solve of. Now when you place this thing x, then the target sum will be now reduced to n minus x, so that's what n minus s. And why k minus 1? Because since you have placed one digit, then your one place is already occupied, so you have to uh, recur for rest of the places. So rest of the places definitely you have to do minus 1, right? And then this last digit as well, which we placed, which we fixed, right? So that this code will consider all the above possibilities that is forming here, right? And what would be the base case? The base case would be like you have occupied all the places, right? And that in that cases the k will be pointing to 0. And when you have occupied all the places, that is k equals to 0, your target sum should be equals to 0, right? Because when you place a digit 2 here, then the target sum becomes 2. When you place a 2 again, your target sum becomes 0, right? So if k is equals to 0, you need to check, you need to return that if n is equals to or to 0, then return 1 or else 0, right? That would be your base case. Let us code this approach and we will see that how it reacts, right? And what would be the time complexity of this approach? That for each and every place we have n possibilities, right? And how many places are there? There are k. So the time complexity will be n power k, right? N power k. And what is the this thing? What is the constraint here? The constraint is 100. So 100 power 100 would be definitely, I guess, greater than 10 power 8. But let us compile, let us code this step and we will see how the code reacts, right? So that's a very exact code I'll be writing here. So let me do that and then we'll proceed ahead. So I have coded the exact steps I mentioned in the pseudocode, and let me repeat it again that this is not an easy question, right? So the recursion happening inside a for loop may be very confusing to you guys, right? So I have made a recursion playlist as well. You can view that to understand how the recursion happens. I have considered the most standard and the complex question as well, and I have showed you all the recurrence relations in that, right? So don't get like say demotivated or anything. So in recursion, we just have to think for a smaller test case and then we need to run it for the larger one in the hope that it will run, right? I have shown you the dry run. Now let us compile and run and see what happens, right? So definitely it should give you TLE, but let us verify that yes, output and expected output matches. Now I'll hit the submit button, right? So definitely we'll get a TLE, but let's see. There is two more optimization left, right? Okay, so only 10 cases pass out of 565, right? So now I highly recommend you again to pause this video again and try. And I have made some red lines here, right? I have made some red lines here. That means that you do not need to consider these all the combination which is below this red line. Why? Because you can clearly see this 2 and 1 is forming a decreasing order groups, right? And the constraint was that it should be in increasing order, right? So do something in the code that it doesn't run for these dry runs, right? Because that will reduce our complexity somewhat, right? But then again, the worst case will be again n power k. But much of the what to say much of the dragons would be skipped, and now you can see only 10 cases pass, but in that case more cases will be passed, but then again we'll get the TLE. So we have to understand, right? We have to go one step ahead. So now please pause this video and try to do some edit in the code, and I've shown you the optimizations. We do not need to consider these possibilities, right? Where either the sum is greater than n equals to greater than n. You can clearly see 3 plus 2 is 5, which is already greater than the sum, right? And there will be cases where it is in decreasing format. We have to skip those. Okay, so you were able to guess it right? So what is the edit that you can do in the code is that you can clearly see for this thing I only need to compare just once. Here I only need to compare just twice, and here I only need to compare just once, and again I need to compare 0 times, right? And this would be this code, whatever the code we have written, this is comparing in this order only what I have written in the dry run, right? So that means I just have to run for each and every. So this is for s equals to 1, this is for s equals to 2, 3, and 4, right? And this will be the order of comparison. So for each and every loop, this is the number of iterations I have written, right? And if you clearly see, can we get using the x and target sum, can we get something so that we can do this? Yes, we can do this. So whenever we are running the loop, we will not run it till last, right? But we will run till minimum of x comma and target sum. Yes, you can clearly see 1 comma 3 minimum will be 1, then 2 comma 2 minimum will be 2, 1 comma 3 minimum will be 1, and 0 comma 4 minimum will be 4. And you can see clearly see that these are all the numbers which is the required iterations for each and every recursions, right? So that means this will be replaced with nothing but math dot min of what, uh, what to say, the n, right? The target sum is uh, getting replaced at the first parameter, and the current sum is at third parameter, right? So it will be last, right? So let us do this optimization and then see how the code reacts. So I have done the optimization, and I'm repeating again here. I have also wasted a lot of time in doing this question, and these questions are not will not be asked in the interviews, right? So we are like just utilizing our time in some not authentic direction, I can say, and that's the reason I'm thinking of maybe more concentrating on my DSA series, because that is the code logic that would be asked, right? Okay, anyway, let us hit the submit button. We know that the TLE will come because the worst complete will again be n cross k, but I just n power k, but I just want to show that this time, due to this small optimization, we have some majority of the comparison will be skipped, and you can clearly see that out of before it was only 10, and now 510 cases passed, right? And the reason that I'm not showing for multiple cases for dry run is because this is a recursion question, right? You just have to run for a small test case and then you have to accept it. You have to make this leap of faith, right? Okay, okay. And that's the reason I cannot find content on comparative programming like the daily solutions, which especially when it is of hard category, right? Because no one maybe it's very hard to explain the complex problems. The standard problems are always easy to explain, right? Okay, okay. Never never the matter. Let's proceed on. Okay, so what should we, so we know that this recursion code is right, and but we are getting a TLE. So to what is the optimization of recursion, right? The optimization of recursion is DP. Recursion is that there will be several sub problems that are being compared, and we have to, for those sub problems, we have to store it in such a data structure, maybe it a array, 2D array, or 3D array, and before and just after this base case, right? Just after the base case and before this processing, right? We need to check that if that processing is already done and stored in our DP array, then you need to take the value from there and stop the function for that particular processing, right? If you're still not able to get it what DP is and how the memorization and tabulation is achieved, right? I highly recommend you that you watch my DP series. The first videos I have made of, and I've explained you very detail in how why recursion is there, why DP comes, and how the memorization and tabulation works, right? Okay, so but in one line, memorization is nothing but whenever you are doing this processing, right? This blue blocks processing, we are storing each and every state, and when you store it, utilize it. Don't do the sub problems again and again, right? So how we can do that? Clearly you can see. So bhaiya, can you tell me like so okay, I know that we need to make a array, or let's say a structure which will store the states, right? But how can I decide that which data structure I need to use, and how to decide that what to make exactly, right? So for that thing, you need to see that how many states your problem is taking to solve, right? I can clearly see that there are three states, n, k, and last. So that means blindly I can say that I will need a 3D array, right? I don't know the logic how to go ahead, but I am sure that whatever the states, count the states in your existing recursion solution, and then you have to make that much size array, right? So let us make it and then we will proceed ahead. Yeah, and before that, so this was the manual dry run I showed you. So if you just want to do code dry run, that how the code is actually working for solving these sub arrays. So that's the dry run I have made here, right? I have written here just to save our time, right? You can you can take a snapshot, right? And you can verify yourself using a pen and paper, right? We're just comparing the above things, right? So let us get back to making a 3D array and then we will proceed ahead. Hmm. So I have made two changes. First of all, I have initialized the DP 3D array, right? Then I'm initializing each and every cell as -1. Why -1? You can initialize with any number which will not be an answer for any recursion you will make, right? Right? Okay. If you are still not able to understand how the memorization works, because I have tried my best to explain you in minimum time, you can again watch my DP series. The first video is there for tabulation and memorization, right? It may be showing up here now, or you can traverse back to my playlist. Okay, so these were the first two steps. We initialize it outside, because why initialize outside the function? Because we need to make it a global scope so that the every this solve function can access it. Now, the second thing was to before calling for a pre-processing thing, right? Processing thing for a particular parameters or the recursion we are doing, right? And after the base case, we need to mention that if that particular state is stored, right, then don't process it again. And how it is stored, you can see clearly that I am just returning answer here. So for now, we will return the answer, but at the same time I will store it in a 3D array as well, right? So that's it. And here I will mention the condition that if it is not equals to 1, then use it, right? So I will just say if if it is not equals to -1, that is the state that we have defined that it is not used, then just return, just use the answer from there and stop. And for stop the recursion we will say return, right? So that is it. Okay, let us compile and run and see. So converting a recursive code to memorization is very simple, right? So what's the error in line number 53? Okay, but converting in this same approach to tabulation may require some more efforts to see that how the array should look like and how the array is to be filled, right? So let us hit the submit button. And now what would be the time complexity for this code? Uh, let us see. Then I will give you the time complexity as well. So you can see that our code got submitted, right? So what would be the time complexity of this code is that we can clearly see that for each and every recursion, right, we have O of n possible values, right? You can clearly see that here. We have O of n possibility, right? And for O of n, and for each possibility, there are three states, right? That is n cross. This last is nothing but a value n which we are starting from, right? And you know that why we passed this last, because this was the optimization I needed to show you for the n, the target sum, and this and the value which is getting passed, right? So for each and every recursion there are n possible values, and for each values there are three states, that is n, k, and last. So that will be n into k, right? So overall time complexity will be n. Overall time complexity will be, let me write it here. There are n possible values for each recursion, and then there are this state n into k into n, right? So it will be n cube into n, and you can see that the n cube into k, let's say, and the constraint is 10 power 2, so it will be nothing, it would, and both have the value of 10 power 2, right? So it would be like 10 power 2 ka 4, and it will be 10 power 8. So whenever you have a row, you have a code written which is less than equals to 10 power 8, so it gets submitted, right? And can clearly see it accepts all the submissions, right? So last things here, I need to say that these questions are definitely not asked in interview, right? I have sat in many interviews, right, and I'm still sitting for that. So that's the great thing. So these questions are never asked in the interviews, right? Maybe you will get these questions in OA, but never asked in interviews, because interviewer there also takes some time to prepare the questions, and They usually go to the top 150 questions asked, right? So I'm spending like from 12 a.m. to this is 4002. So 4 hours in a question of doing and explaining it to you, right? So it is nothing but maybe not the efficient utilization of the time whenever it comes to a hard question, right? Medium and easy question are still relatable, that can become. But yes, let us see what we can decide in future, right? Whether should continue or not, because it is really not asked, right? I'm like pretty sure. The last time also the hard question was there, right? And it took a lot of time, and maybe after seeing the video also you would be in several disagreement. There are some test cases which were running and some tests which were not running, right? So definitely we are not sometimes we are not working in a right direction, as we say. So with that note, let's end this video and then we will see that what are the next steps that we can take, right? So till then, keep learning, keep growing. Bye bye, and take care. And this is my DSA repository. You can start and fork to get help with the source code. I can already see 27 stars. And the last thing that I need to show you the C++ code as well, right? So let me do it. So that's the C++ code here. I have submitted that code as well, and it got submitted, right? So let me scroll it for you. It's the same as we coded in Java, just some syntax changes, right? So it will be helpful for C++ as well. So I will make a gist on a GitHub gist, and I'll pass all the approaches from brute force to optimize in C++ and Java as well. And there is one homework for you. I don't require that thing, so that's why I'm giving it to for you guys. So whoever wants, you can convert this memoization code to a tabulation, and maybe you can comment down that yes, this is the code. Everyone can help. So let's not make this video too long now. We have already understand. So let us end this video. Till then, keep learning, keep growing. Bye bye, and take care.